So our agenda will be first part GPS concept and then the GNSS revolution. We will talk about basic terms and technologies. Then we will talk about the NMEA. And we will make a short demo that will show that theory was the reality. And we will talk in the end about obstacles, performance, and the last session will be the question and answer. So if we are talking about GPS basics, I can tell you that it's very complicated topic in terms of physics, mathematics, algorithm, RF, software, real-time embedded cloud, etc. As you can see here, there are a lot of topics to handle, and I will try to explain in a more simple way how we look about it, what is important in this world. So if we are starting to talk about GNSS, you can see here a red point. So for example, this is a GNSS sensor, a receiver on our Earth, and you can see here a satellite, how they going around on the sky. And every time we can see that we see different number of satellites. Okay, it can be 5 satellites, 10 satellites, and the satellites are sending information to the Earth, and the sensor of the GNSS or GPS receiver are calculating the information and making the position, as you know, the time and everything. So this is the basic idea of GPS. If we will go into the satellite information, so is transmitting bits information. Our receiver is getting the information in delay. You can see it over here. And then the receiver should calculate and make the acquisition process to be in correlation with the received signal. So now we can see that the acquisition part finished, and we can start with the calculation. What is the method of the calculation? So we have here satellites transmitting information, and the receiver received the signal and made a replica of this signal. So now we can calculate the time difference. If we will calculate the time difference, so we can know the distance between the satellite to the receiver. And it's a simple method of calculating pseudo range. This is the distance, because it's not the exact distance, it's a distance that we are calculating according to the replica. So we are using here the time arrival and the speed of light. So this is the basic of the basic. We can go more deep in this part, but let's stay and keep in mind what we talked about here. So let's move to the GNSS revolution. Basically, we have more satellites around our Earth. We have GPS, GLONASS, Galileo, BeiDou. This is the beginning of GNSS revolution. If we look another picture, so we can understand that every country have its own technology of implementation. Means that all of them want to make the same concept as GPS, but it can be a different implementation. Another term here is G3B. It means that we have your GPS, GLONASS, Galileo, and BeiDou. This is the basic GNSS, but today we have more technologies and implementation. For example, QZSS, SBAS, and NAVIC. Another part to know here, we have a lot of RF parameters. For example, what will be the frequency of GLONASS and GPS? What will be the bandwidth of each signal? What is the RF modulation? And there are more topics. Let's move on to the NMEA implementation. So this is the standard of making all this architecture and and the implementation going into the NMEA format. Here you can see the standard packet of NMEA. How should it look like? So it will start with $, then we will have few fields and a checksum. If we will talk about example of sentence, so we have a GGA sentence. GGA will report us what is the location of the receiver. Okay, it will tell us what is the time of the position, what is the number of satellites, and more fields that you can see over here. Another example of NMEA sentence will be the GSV, which will indicate the location of the satellites. What is the location of each satellite, if it's GPS, if it's GLONASS, if it's Galileo, or more types of satellites. What is the quality, the signal quality, and more topics that we can see here. If we want to move forward, so the important part, how we analyze this information. Okay, we have a lot of information inside the NMEA. So the best way to handle it is by visualization of NMEA. For example, here we can see a GSV sentence, and we can see, for example, satellite GPS with ID 2. So this is the signal quality. A Beidou satellite with ID of 3. So this is the signal quality. And here we can see a few satellites, what is the quality, and if we use them or not. Another example is the fix and how much satellites do we see and use. So you can see the green part, the satellites that we see, the red part, the satellite that we use. Another part is about handling the NMEA and making not just read and visualization, but also taking the NMEA and making algorithms. For example, here it's algorithm of max hold and minimum hold. So I can know what is the signal quality in total, not looking about every satellite specifically, like this picture, but taking all the values together and see what is the minimum and maximum. And also we can see here the part of the fix. We don't have fix, and then we have a fix. What does it mean fix? That we manage to calculate the location. And the last picture, an example, is the velocity. You must understand that the calculation of velocity is something else. It's not taking one point and other point and then calculating velocity, but it's coming from the Doppler effect of the calculation. While taking the signal from the satellite to the receiver, we have Doppler effect, and this will give us the calculation of velocity. So we finished with the part of theory and reality. I made it super quick because it's a complicated topic and I wanted to simplify all the important details. I will talk after the demo about few more things that will close you the picture. And now let's move to a simple demo that I want to show you. Before starting the demo, I want to show you our GNSS receivers. For example, if you want to implement all this concept of GPS GNSS, so you can plug and play these products into the computer and immediately get a location. And our setup, our demo setup today will be the satellites that we have always around us. I took a module of OriginGPS and put it on our roof. And now I want to plug this module to the computer and see the NMEA visualization as we talked about. So one moment and I will show you it. So now you can see a real-time satellites. For example, these are the satellites that around us in the location of OriginGPS. You can see a lot of satellites. You can see their signal quality. In this case, we have L1, L5 module. And you can see that we are tracking all the satellites. We can see here a location. We can see here a velocity calculation. The velocity should be stable because it's a static test. Here we can see the number of satellites that we have around us. You can see that we are not using all the satellites. For example, we talked about the GPS basics. So we will not take all the satellites into the calculation. Maybe some of the satellites are wrong or have an issue, and then we cannot trust them during the use and calculation, because they will give us, for example, if we want to have 1 meter accuracy, it will give us 5 meter accuracy because they have issues in the transmission of the information from the sky until the Earth. So this is the reason that you see few satellites with color and few satellites in blank. Another part that I can show you here is the DOP values. For example, I can monitor what is the quality of the fix of the position. So here we can see that it's lower than half. It means that the quality is very good. And another part, we can see here a few types of fixes. For example, let's send a reset to the module that it will start the process. What is the process now? Sending the information from the satellite until the receiver. And now we are starting the acquisition part. So you can see that we don't have any information now and any information here. We're just trying to collect the information. So it's taking a few seconds, something like 30, 40 seconds. And now you can see, okay, we got all the satellites. Now it's starting to use a few of them. And the goal is using as much as possible, because more calculations will give us better accuracy. So this is a simple demo that demonstrates the reality against the theory. You saw here all the progress that we talked in the last slides. And now let's move on. Let's talk about the difficulties, the performance, the analyzation, statistics, all these parts. So the idea, if we talked about one calculation, so you can see that we need at least 3 calculations, at least 3 different satellites in order to get the position of the GNSS receiver. If you want to call it, you can tell that it's also a GNSS sensor. It's another way to think about it. In reality, we have a lot of delays and effects, and then the calculation starting to be more complicated. And then we should get at least 4 satellites if we want to get a position. And if we will look more deep, so the acquisition starting to be more complicated because we have the troposphere, ionosphere, and the errors that coming from the satellites, from the receivers. If we will talk about this equation, so we can demonstrate this picture. You can see here that the satellites are around 22,000 kilometers higher than us. And then we have few types of atmosphere, for example, ionosphere or troposphere, that making a distribution, making a disturbed signal quality and affecting this calculation. And there are also values for this. For example, what will be the miss accuracy because of the ionosphere. So you can see here that the error will be 1.2 meter. So there are more errors that coming because of this. Another part to talk about is the multipath. So if you are thinking about satellite, we will get as a receiver direct signal, but we will get also a replica of the signal or few replicas of the signal because of the obstacles. Imagine that you have urban environment and you have buildings. So all the buildings will bring a few signals to the receiver, and then all the calculations starting to be wrong because we have the same signal few times. So this part we should handle as users, as engineers, and we as OriginGPS trying to help to solve all these problems and obstacles. So the important part after we will have a product with GPS or GNSS module is to analyze the performance. So we have the tools, for example, this one of the tools, to analyze what is the performance, what is the quality, and to get into conclusions how we can improve the performance. For each type of application, there are different analyzations. For example, if I am a dog and the tracker is for dogs, it will be different application than car trackers. We need to talk about the scenarios, if we need to be 24/7 of tracking, or there are different scenarios. And for each topic, we will handle differently the part of performance analysis. If we are talking about statistics, so it's not good enough to take only one measurements and see what is your performance. You should take at least 20 different measurements and then make a statistics calculations. For example, here you can see what is the accuracy during 50% of the positions. So we can see that the accuracy here is 0.3 meters. And there are more parameters that you should take care about, and it depends about your application.